going to give you some notes which are important for the test. Rich, you mind turning off the lights there for me, please, and thank you. Okay. On page 94, right, everybody? Okay. So I want you to write down uncertainty versus tolerance. Some students, after a while, think they're the same because you have some plus and minus in front of both of them, but they're not the same, right? So I'm going to kind of split this in here. So the main difference is that uncertainty, right, is caused by the limitation of the measuring device. Instrument, device, yes. So the uncertainty, remember we get our uncertainty from the precision, right? So precision and uncertainty are very closely related. The uncertainty is half of the precision. So that is what it's called. It's also known as the margin of error. Okay, it's like how much you could be off by. And it's basically, what do I want to say here? I think I want to say something like set by the device, right? Set by device. If that's catchy enough, right? The uncertainty is because of the device that you're using, right? Tolerance is different. Okay. It is the range of acceptable values so that the part, right, the part can still be used. Okay. The range of acceptable values so that the part can still be used. Why is that? Caused by, bless you, human error. Bless you. Equipment malfunction, something's breaking, or limited precision. Something is going on here. Okay. So make sure you write this down and I can explain maybe a little bit more. I would say that who sets the tolerance? Like what decides what the tolerance is? Yeah, set by industry, yes. I would accept that answer, manufacturer, yeah. So the tolerance is, if the industry sets it, Obviously, you won't be able to get the same piece exactly the same every time, right? Even a Coke can, if you were to like really like measure the diameter of every can, the height, it would always vary a little bit, right? So we understand that when you produce a lot of items, that there's always going to be a little bit of there's going to be a little difference from one part to the other, but that's okay, right? So the industry sets it like there's going to be a certain amount where that is no longer tolerated, right? So you have to discard it either on the high end or on the low end, right? So I always see tolerance as, right, there's a low, right, and a max, and everything in between here is acceptable, right? Which is the range. It's the range of acceptable pieces. So anything above it or below it will be discarded. When you talk about like at kitchen graph, it would just be either run again, like they would use it for a different piece that was smaller, right? So if you're discarding a piece, I can't use it for this, but we can use it for a different style of cabinet, right? So you just machine it down even more, you recycle it, so you recoup some of the cost, not the whole, right? Um, some of it would be firewood, right, to heat the building. So, um, and then I want you to have some examples. So this is where I cut it. I kind of cut this here. And so just make sure that page 94 has uncertainty and tolerance right next to each other. Okay. And so you should be able to, using your own words, explain the difference or at least identify, which one would be uncertainty, which one would be considered tolerance, right? All right, and then I need you to have some real life examples of tolerance. I'm going to give you a template, right? If you see that something has to be large enough to ... small enough to ... right? That is in essence tolerance, right? You have like a upper and a lower limit, right? And so that's going to be our template. Okay, so let's do prescription. Prescription drugs. So if you want to be a legal drug dealer, just become a pharmacist, right? Have you heard that one before? Yeah. That's really what they're doing, right? Like they just give you a certain dose so that it's safe, right? Prescription drugs. In this case, if you needed to say something regarding to this, an example, right? You would have to say that the dosage has to be high enough to have the intended effect. So it has to be high enough for it to have the intended effect, but low enough to prevent an overdose. Okay. We can talk about electricity. Two examples. That's all I'm going to give you, and you will come across them in the workbook. a battery has to have a high enough voltage to run the device, right? But low enough to prevent a surge, right? Overload, and therefore damaging the device, right? So if a battery is labeled 9 volts, there's a chance that it's 9.5 or 9.4. It's okay, right? So it's okay to be just a little bit higher, but it can't be too high because then you might actually damage the device, right? 94. It only takes a split second, guys. If you ever, like, I needed to find an adapter. I think it was just an MP3 player or something to charge it. This was like a long time ago, right? Nowadays they're kind of universal, but every plug has slightly different voltage, right? When you just plug it in to recharge, and it takes seconds. You plug it in. If it's too much, the thing is fried, right? So you want to be very careful. Make sure the voltage is appropriate. Right. Yeah, the device itself has a way. Exactly. Yeah, yeah. It might, or it might have like a fuse inside that just, yeah. Yeah, you're right. Yeah. You know when your breakers, you know what a breaker panel is in your house, right? You've tripped it a couple of times. Maybe you had a heater plugged in and a blender at the same time, or something that uses a lot of juice, right? If it's on the same circuit, it's gonna pop, right? That's actually to protect your system, your wires from overheating, right? Because it draws a lot of heat, right? If it's overheating, that's when you start a fire. The junctions can melt, right? The what do you call it? The jacket, the insulation on the wires can slowly melt, and then it touches. Maybe it causes a spark, and then you have a fire, right? So yeah, that's the same idea. Right? Same idea there. There's a bit of tolerance though, right? You can run both elements for a certain time and then it's going to pop, right? It's not going to pop right away. So trip, whatever you want to call it. Yeah. So it's there to protect you. The time on the from a red, right? When you go from a green light to a red light, right? Green, yellow, red, like there's a little bit of tolerance, but the other way, not so much, right? Going from red to green, it almost jumps right away, right? And so it's obviously to make sure that there are fewer crashes, right? That's why you have the slow going to red. Has everything to do with tolerance there as well. Police officers, right? When they do the radar, they're speeding. They're trying to check for if you're speeding or not. I'm sure they have some tolerance, right? If you're going 54 on a 50, I'm pretty sure they're gonna let you go, right? I'm recording this now. I'm gonna get in trouble, but there's probably some tolerance, right? They're not gonna be like, oh, 51, right? You're speeding, because they know that cars can be off. The equipment itself can be off, right? So a lot of things. Maybe if there's a certain amount of humidity in the air, it affects the accuracy, right? So keep that in mind. All right. Let's do some more converting from one to the other. So you put this aside for a bit. That's page 94, and you go to your workbook. I asked you on Friday. What I wanted you to do is take this one, fill in this chart, and then rewrite it in the 3 other formats. Now, this should have been the case already, but if you do not have this on your study sheet, here it is one last time, right? You should on your study sheet have the 4 ways to state tolerance, right? You should have that. There's max, min, like this, and this is in no particular order. Then you have max, you have min, and you have nominal. When you have the max, when you get this number, it should be plus 0 minus tolerance. If you have the min, you go minus 0. You can't go any lower than that. Plus tolerance. And then nominal is followed by plus or minus 1/2 of tolerance, right? So these are the 4 ways to state your tolerance. You need to be able to, I can give you any one of these and you should be able to branch off into the other 3, all right? That's the idea. A little note, this one right here, to get the nominal, if this is given to you, you would go max plus min divided by 2, right? Only for this, okay? This is exclusive to that one. And I also told you that all 3 of these, the other ones, that first number, yes, it's the max, yes, it's the min, but it's always the nominal as well, right? Always. That first number, if I asked you, if I gave you this, like, what's the nominal? Boom, right? That number. What's the nominal here? Boom, right? But then later when you fill in that chart, you might come up, it's like, wait a minute, it's the minimum as well, right? It's okay, right? It would be the nominal and the max, nominal and the min, right? And nominal, obviously, it's right there. Okay, you should always be able to fill this in. Right? These 4, you should always be, I can give you any one of these. You fill in this, then you branch off to the other ones. Tolerance, I don't know, do you know that one? There is a formula. You gotta know that here, here, and here is just given, right? But if you aren't given that, tolerance is max minus the min, right? If you need to use a formula, which is also here, right, from this one, you want to put this here. Rather, tolerance is max minus min. It kind of goes with this first one, so it's kind of like a special case. You will for sure need this one. Some students can just look at it and figure out the tolerance. I would strongly recommend you use your formula. So for this type, you need these 2 yet to fill in this. So I will leave this. I will take this out here, okay? And just keep these 2 formulas attached to the first form. To be honest, most of the time on a test or so, I will not expect you to state the nominal out of this one. Most likely not. Because it's not always safe to assume that it is in between, but if I don't give you anything, you have to use this, right? You have to use nominal. It's just adding these up and dividing it in half, then you're finding the midpoint between the 2, right? So I will see you a little bit later. Right now, your task is to work through this page. Remember, I tell you this, right? The first one doesn't, but I want you to still do it. Like there's state in 4 different formats, right? And 4 different forms, right? Like question 3 and 4 definitely ask you that, right? But I want you to do 1, 2, 3, 4. You see the back side. Yeah, you can do that one too. So 1 to 5, 6 and 7 right now. If you feel like you're ready to go there, you can answer those as well. But I want you to do this tolerance worksheet in the meantime, all right? So a little bit of work today, tomorrow, and then test Wednesday, all right? You wouldn't mind grabbing a seat for now? Oh, I'm already ahead of you guys. Hold on. Backtrack a little bit. It's frozen. Yeah. Let it go. Let it go. Okay. So, guys, there's a little bit of common sense required, a little bit, and then the rest, if you just follow, it should be connected, right? So this is, if you see that, you should recognize that this is one of the 4 ways to state tolerance, and it looks like that. So all you need to do there, just make sure your units are there if you want full marks, okay? Tolerance would be subtracting these two every time. It doesn't matter where you get your tolerance from, you should be able to subtract the max and the min and get the same, okay? Every time. Nominal, we don't know what it is off the bat, so we need to actually use this formula, and you get 4.1, correct? All right. I asked you to write it in the other formats, right? So I'm going to do max, follow now, okay? Max plus 0 minus the tolerance. Make sure your units are there. The other one is min minus tolerance, sorry, minus 0 plus the tolerance. There you go. And the last one is nominal, which is right here, 4.1 plus or minus half of whatever the tolerance is. And there are your 3 formats, just like that. Okay. Next up, a steel manufacturer creates an item that must be a minimum of 5 centimeters across with a tolerance of 0.2 centimeters. Express this in the following form. So it wants you to express it in this format, right? It's basically saying, hey, state the tolerance like this. This one is actually not too bad. You just go 5 centimeters, and the max will be what? How would you get your max? If you're not sure, you do one of these. Okay? Your tolerance is 0.2 centimeters. Your min is 5. To go from the min to the max, what would that be? It would be a tolerance, yeah, a tolerance of a difference, right? So this would be 5.2 centimeters, and there you have it, okay? Because you always know that the difference between these two is your tolerance. Okay, so there's a 0.2 centimeter tolerance. That's it, check, okay? A company manufactures cylinders, and this must have a maximum mass, so that's 4.82 here, and a tolerance of 0.24. Okay, state the tolerance in 4 different formats, so they're kind of filling in the puzzle to a certain degree. So to get your min, right, when it's like this, we would just subtract the tolerance from it. So to go from here to here, just go minus the tolerance, right? And what do you get there? Let me see if I have that here. And that'd be 4.58 kilograms. The nominal, we don't know what it is, right? So we would just find the average. If you don't know it, you need to find the average, right? So it'd be 4.82 plus 4.58 divided by 2. And that's, wait a minute. Yeah, that's what you would do in this case. What did you get for the average? Exactly. Okay. And so the other 4 formats, we just go pick one random, right? This is one of them. I kind of box that in. That's one of them. Then you take the max and you add nothing to it, but you would go minus 0.24 kilograms to get your format right. And you take the lowest. You can't go any lower than that, but you can go up by the tolerance. Make sure you have units everywhere. What are we missing? We were missing the nominal, 4.7 kilograms. Actually, let's stick with 2 decimals, right? Like everything is in 2 decimals. You wouldn't lose marks in this case, but that's what we should do to be consistent, right? So that's your fourth way of writing tolerance. So all 4 are there, okay? I think this is what I need to add. Some of you are probably like thinking, how did you get from here to here, right? To go from one to the other, it's always tolerance, right? To go from the lowest to the highest or the highest to the lowest, it's always tolerance. So keep that in mind. Okay. Next, there's a maximum of 20 grams, a minimum of 16. They give you both. The tolerance is 4. The nominal we don't know, so we'll just go 20 plus 16 divided by 2. That is 36 divided by 2, which is 18 grams. Okay? And let's state it in 4 ways. Max min. You already have this, so I'm going to kind of just rush through it a bit. 20 grams plus 0 minus 4 grams. 16 grams minus 0 plus 4 grams. And the other one is 18 grams plus or minus 1/2 of 4 grams. There are your 4 ways of stating your tolerances. Okay, you're like, I sort of get it. Why would I need this? As a machine operator, you should be able to look at any one of these and be like, oh, I got this one just now. That means that the maximum is 20 and the lowest I can get is 16. So when you run that machine and you weigh, you do your quality control, you make sure you stay within this. You should also be able to figure that out by looking at this or this. This will be the easiest one, right? As a machine operator, it's in between here. But sometimes they actually really want you to get that target, right? The industry that you're in, it's like, no, we actually, if at all possible, we want 20, let's say here, right? 20. But if you're a little bit lower, that's fine. But we're aiming for 20. Here we're aiming for 16. If at all possible, your machine should be making them at this. If you're a little over, that's fine, right? So there's different emphases in the different ways to measure it, right? Here, this would be a case where you kind of want it at 18. You can be over or under. That's fine, right? But all 4 of these tell you what that threshold is. All right. This one is weird. This is a weird one. Do you notice that? There's no 0 there. Watch out for that. They're not that complicated, but to get your maximum, you just add. 45 plus 3 is 48. What are we in? Centimeters? Minimum, you subtract. 45 minus 3, that's 42 centimeters. What's the nominal? Always the front number, yes. When it's stated like that, the big number in the front is always the one that goes. The only one that isn't is when they're stacked like that, max min. Then you need to use the formula. Tolerance is 48 minus 42. That's 6 centimeters. And if you think about it, to go from -3 to +3, right, there's 6 centimeters of range acceptable. So there we go. Maximum, 30 plus 0. Oh, that's 30, right? Minimum, 30 minus, that's 25. Nominal, glad you asked, right? It's just the 30. And you notice that maximum and nominal are the same. That's okay. Tolerance, you can subtract these two or just look from 0 to 5, right? That's a 5 centimeter tolerance. 5 centimeters that you're allowed to be off, right? On the low end, right? It's got to be low. It can't be higher. Okay. Number 7, guys, is I just gave you notes on that. State an example from the construction, commercial, industrial, or artistic industries where a certain degree of tolerance is required. Support your example with an explanation as to how tolerance was required. So, anybody have a good example in construction of tolerance? I don't know. I feel like I did a little bit of like basement work, like trying to do basement. Everything is so like approximate that it's if you're off by a little bit when you're framing that, because they're going to pour the concrete into those panels, like if you're off by a little bit, not a big deal. If you order concrete, you never order just enough, you always order more, right? So in that case, you would probably want not that one, you would probably want the one that goes up by a little bit, right? Like you probably want, hey, I want 3 yards, 3 cubic yards. If you're over by a little bit, that's fine, right? Because you don't want to run out of concrete, because once that concrete starts curing, you don't want to like wait for another truck and pump fresh concrete on top of old concrete. It's not cool, right? It's not, they're not going to bond together, and you could have a crack in your basement and it just gets really ugly, right? Um, we're going to move on now a little bit. We're going to review uncertainties. So come with me, page 14. I want you to go through page 14 and 15. It's talking about precision and uncertainty. The front is just straightforward. You know what that is. The back side, guys, careful with the back side. You remember when we add or subtract measurements and they have a certain uncertainty, we always add the uncertainty as well. So the back side is going to get you to go through that and review adding and subtracting values with their uncertainties, okay? So I would expect you to get that done today, right? And if you do so, I'll just not give you an AC today. How's that? If you work, right? So take that. I'm going through it quietly, so if you want to look up and check, it's up to you. If we got that part. Just a reminder that the precision can be presented to you in three ways. It mentioning what it's going up by, just giving you the measurement as a value, and the picture of that, of a gauge, of a ruler, of anything, right? So you just have to go by that. Backside. They were nice enough to give us the uncertainty. Combined weight. I just write them all like this. And then I don't worry about precision. You never add that, right? So you would just add these numbers. Right? You get 22, and then plus or minus, and you add this up. Make sure you add it or times that by 3 because they're all the same. You get this. That's the combined weight with the uncertainty. You can get the max and the min from this. The greatest possible and the smallest possible weight, right? Just keep that in mind. Same as tolerance, but this is not tolerance. We're talking uncertainty here, right? How much could we be off by, potentially? We're cutting off here. What's the length including uncertainty of the remaining piece? Precision is 0.01. Uncertainty is half of the precision. 2.61. Same precision, same uncertainty. It's not always going to be the case, but we subtract here. Don't worry about precision. We always add the uncertainties, right? So minus would be 5, 4, you get 9. We were left with 4 minus 2, 2, right? 2.95 meters plus or minus. When you add that up, you get that many meters. If you add these up, your calculator will give you this. And you're cutting off, so you need to subtract measurements, right? I think I'm going to go straight to 10. Let's finish off with 10. 10, I don't know if you noticed, but they all have different, well, not all, but quite a few of them have the same precision, but others not. Okay, what's the total mass of the combined uncertainty? And then I want to tell you one more concept that I will test you on. So we have 563 kilograms. Precision is 1, uncertainty is 0.5. I'll take the other package, this one, 1125 kgs, because the precision is the same, uncertainty is 0.5. Right, so this is gone, I'm adding these two, and then I will take the 69.0, precision is 0.1 because of that. Uncertainty is half of that. I take the other package, the 10.05 kgs, precision here is 0.01, right? Because it goes 2 decimals. Uncertainty is like that, right? You take half of that precision. We are obviously going to add all of these because we want the combined mass. We're also going to add the backside. If you add this all up, you get 1,767.05 kgs. Make sure you cross out the precisions. I don't want you to add them there. Plus or minus, if you add all of this up, you get 1.055 kilograms. So you can be off by about a kilogram. You could be. So what would be better? Instead of weighing all the packages separately, what would be more accurate? Right? Weighing all pieces at the same time would reduce the uncertainty. That's very important concept to remember. Instead of luggage, right? Luggage, even though it wouldn't be practical, but I'm sure that when the attendant weighs all the packages individually, I'm sure that they go on to one big container, and that whole container is being weighed one more time, right? To kind of remove that uncertainty that was created by weighing them individually. Anybody worked in that area? Probably not yet, right? Where you check in the luggage. Maybe you have someone that does work in there. Can ask them.